everyone! A great majority of today's presentations demonstrate how we can use thermodynamics concepts to simulate real-life processes and experiments. Now this project aims to do just the same, but in a classroom. Let's see how we can do this. Professor Harvey launched the project for the thermochemistry course he gives at Polytechnique and completed his team with Anya, whom you've met earlier this morning, and myself, who took the course in fall 2019. So, to give you a little more context, in course evaluations, students often raise the fact that the theoretical concepts covered in thermochemistry such as enthalpy, entropy, Gibbs free energy, or fugacity are hard to understand and apply. Furthermore, they don't feel like they learn enough about the industry's reality. Indeed, here are a few testimonies from chemical engineering students who think it would help them in their internships if there was a bigger emphasis in their curriculum on how equipments are commonly used in the industrial production lines, as well as their design specifications. In an industrial perspective, this project aims to prepare students better for their future jobs and internships. We want to push their knowledge further on commonly used industrial equipment and stay up to date with new technologies. So if you are here today and working in the industry and you think this makes sense or have any other comments, I invite you to get in touch with us. Your opinion could help us greatly in the process, and also we want to get students as close as possible to you and your reality in the industry. So in a more academic perspective, one of the goals is to increase the students' motivation level by linking highly theoretical concepts to industrial processes. To do so, we'll take the generic examples currently presented in the course that are taken from classical books and replace them with more tangible examples in which real operating data and equipment specifications will be used. To achieve those goals, we reviewed 150 internship reports from the last 3 semesters. This helped us identify the main case studies we'd cover more in depth. We then searched for specific operating data on the chosen processes to find all the information we needed to build thermodynamic problem sets. Finally, we produced short introduction videos on each processes. So this graph, based on the 150 internships reports we reviewed, can quickly show that the mining and metallurgical industries, as well as the energy and environment, are the 2 most popular sectors of specialization for internships in chemical engineering at Polytechnique. And since we have expertise at the CRCT in those subjects, it only made sense for us to choose some processes that were related to the subjects. Which brings me to the selection of the case studies. So based on the reasons I just gave you and a few more selection criteria, we chose to work on the aluminum production, the power cycles with residual energy recuperation, and wastewater treatment. For those processes, in the literature, we went to look for thermophysical properties, processes flow sheets for mass and energy balances, as well as real industrial equipment specifications and design guidelines. To build the problem sets, we'd identify the most important concepts we wanted to cover in the course and linked those concepts with the processes through adapted problems. So for example, we used specific units from the processes, such as the Aliahu electrolysis cell, and inspired ourselves from existing generic exercises to recreate real-life problems. So to integrate these new problems to the course, we decided to change the format of the evaluations. We started with homework that had more individual-oriented work, to open problems with different tasks, and project reports. This is to stimulate as well as possible a real engineering team dynamic and promote teamwork. Finally, we produced explanatory videos to introduce students to the processes and help them put in context what they will see during the semester and help them create links between thermodynamics and the processes in real life. Now, if you think your company or the process you're working on could be featured in upcoming projects, just let us know. It could be a great opportunity to promote your company to possibly future interns or employees while preparing them better for the job. You can give us your feedback on previous experiences you had with interns or young graduates, and make sure the next one will meet your needs. Thank you all for your attention, and we hope we'll hear from you soon so that we can work together to make this practice become a more common one in engineering education.